Number 1, explain why the ions of sodium and chloride are strongly solvated in water but not in hexane. Now, hexane is a solvent composed of nonpolar molecules. The water molecules can disrupt the ionic bond, so it can pull apart the sodium and the chloride ions. The nonpolar hexane molecules are only held together with dispersion forces rather than water's hydrogen bonding. So because hexane is a nonpolar molecule held together with, then they aren't strong enough to overcome the ionic bond between sodium and chlorine. Number 2, explain why solutions of HBr in benzene, which is a nonpolar solvent, are non-conductive, while solutions in water, which is a polar solvent, are conductive. HBr will not break into or form ions in benzene. It will stay intact and simply solvate. So it will be surrounded by the solvent molecules. In water, HBr will ionize the water molecule and it will create ions in solution. In fact, it creates as hydronium ions, or another way to look at that is it donates a proton. It donates that hydrogen ion. We'll look more into weak acids in a later module. Number 3, consider the solutions presented, and we have this image, X, Y, and Z. Number 1, which of the following sketches best represents the ions in a solution of iron nitrate? Iron nitrate is an ionic compound. As an ionic compound, we can look at it as a strong electrolyte. So we would have ions in water. So what these blobs within the images show, because we have a liquid water substance, a blue water substance, we need to find a cation, so we need our iron, and then we need a nitrate. Now these bits right here with the blue surrounded by 3 red, that's going to be our nitrate. Whereas this part right here, that's our iron. In this situation, we have our iron, but then we have 3 nitrates joined together. That's not going to happen, although we need 3 nitrates for each iron. The nitrates aren't joined together. The nitrates are actually surrounding the iron. So this is an iron nitrate compound as itself. It hasn't broken into pieces. So Z is going to represent what happens when iron nitrate is solvated in water. All of those ions break apart. Number 2, write a balanced chemical equation showing the products of the dissociation. So for the dissociation, we are just going to have our iron nitrate and show that it breaks into the ions. So we'll start with solid iron nitrate, and it breaks apart into aqueous iron 3 and 3 aqueous nitrate ions. Number 5, what is the expected electrical conductivity of the following solutions? Sodium hydroxide. This is an ionic compound, so I expect high conductivity here. This is hydrochloric acid. Although this is a covalently bound compound, I do expect high conductivity here because in water it breaks apart. Hydrochloric acid is one of our strong acids. It completely dissociates into its ions, although it starts as a covalent compound. Glucose, I expect no conductivity for a glucose molecule. A glucose molecule is a covalently bonded molecule and it does not ionize water. For ammonia, I expect low conductivity. Ammonia is one of our weak bases, and we'll work a lot with ammonia in a later module. And finally, we'll indicate the most important type of intermolecular attraction responsible for solvation for each of the following. So we need to start with figure 2. Figure 2 is found here. We have our ionic compound and water. So this is our ion-dipole interaction. For methanol and ethanol, these are our hydrogen bonding interaction. That's what we need to be concerned with here. Between methane and benzene, we have dispersion forces. Between a polar halocarbon, dissolved in a polar halocarbon, we're going to have dipole-dipole interactions. And between oxygen and nitrogen liquids, we're going to form an ideal solution. So we're going to have only dispersion forces, if any forces at all.